Hello, we're going to be looking at a few different strategies for division today. We can think about division as finding how many groups that are a certain size. For example, when we see a problem like this, 12 divided by 4, we think of it like this. If I have 12 children and I'm making groups with 4 children, how many groups will there be? One group of 4 would be 4, 2 groups of 4 would be 8, and 3 groups of 4 would be 12. I kept making groups of 4 until all of the children were in groups, and I can see that there are 3 groups. So 12 divided by 4 is 3. This strategy, called repeated subtraction, works for larger numbers too. Let's say I'm trying to solve 672 divided by 4. I can think, how many groups of 4 are in 672? I could subtract groups of 4 just like I did for 12, but it would take a very long time if I subtracted them one by one. Instead, I might subtract as many groups as possible at once. It's important to organize the information to help you keep track of how many groups of 4 you have made. Here's a common way that many students like. You can draw what looks like a line on the right of the division problem to help keep track of how many 4s have been subtracted. It makes it look like a giant 7. But really, it's a math graphic organizer. Let's solve the problem. I know that 100 groups of 4 would be 400. So I record and subtract the 400. Now I still have 272 left to make groups of 4. I cannot make 100 more, but I know that 50 groups of 4 would be 200. Now I subtract out the 200 and have 72 left. So I could not subtract 200 again. But I know that 10 groups of 4 is 40. When I subtract those out, there are 32 left. I know that it will be 8 since 8 times 4 is 32. Now I can see that I subtracted 150 and 10 and 8 groups of 4. That's a total of 168 groups. So 672 divided by 4 is 168. But what if I were dividing by an even larger number? This strategy of repeated subtraction also works with large numbers. You can subtract equal groups of 32 just like you did for 4. This time I'm going to use an open array to organize my thinking, but notice that I'm subtracting groups just like I did on the previous problem. You can use either way to organize your thinking. Let's begin. We're dividing 480 by 32. So that's so many groups of 32 is 480. If we're going to use an open array, it may help to think of this as rows of 32 in the array. So I will put a 32 at the top. I know 10 rows of 32 would be 320. So I can subtract 480 minus 320. Now there are 160 left to put in groups of 32. I know that 3 times 32 is 96. 160 minus 96 is 64. Now I know that if I subtract 2 more groups of 32, that would be 64. When I subtract 64, I have 0 left. Now I can see that I subtracted 10, 3, and 2 groups of 32, or a total of 15 groups of 32. So 480 divided by 32 is 15. You might be wondering if these strategies work if there's a remainder. So let's do a problem that has a remainder. What if you were to divide 378 by 25 instead? 10 25s is 250. When I subtract that, I would get 128. 4 25s would be 100. And there would be 28 when we subtract. 125 is 25, and there would be 3 when we subtract. Since we cannot make another group of 25, the remainder is 3. And we can see that 10, 4, and 1 would be 15. So we have 15 remainder 3. Of course, we always have to remember to consider the context. If there were 378 students traveling with 25 on a bus, we would need to round up to 16 to make sure even those last 3 students had a bus. But if we had 378 pencils that were being shared with 25 students, then each student would get 15. The 3 would just be extras. Since we don't know our context here, we can just say 15 remainder 3. Thank you, and please let your classroom teacher know if you have additional questions about these strategies.